All right, hello there, folks. I know that several of you missed class, and there were several questions about the proving argument section that we did. So I thought I'd just go and make a quick video describing how to do one of these problems. So this is section 2.5 out of our book, and it's on verifying that arguments are true. You're going to use this quite a bit if you get into law, if you get into philosophy, if you get into anything where you need to prove that something is true. All right. So here's how you go about doing one of these problems. Let's look at number 5 specifically here. You are going to start with several premises, they're called. All right. I'm going to start with, I have 3 premises right here. And then we're going to make an assumption based on those premises. And that assumption may be right, it may be wrong. For example, in number 5, my premises are going to be, if you buy from a reputable breeder, then your puppy will not require shots. My second premise is, if you do not buy from a reputable breeder, then it will cost you extra. And your third premise, it will cost you extra. Therefore, your puppy will not require shots. That's the theory that we're going to go off of. This is the conclusion, it's called, based off of these 3 premises. All right. Now I'd like to first off define several simple statements that we're using within this argument. All right. I'm going to call these P, Q, and R, just like normal. So P, if you buy from a reputable breeder, I'm going to start out with that statement, buy from a reputable breeder. All right. Q statement, I can say something like, then your puppy will not require shots. Your puppy will not require shots. Shots. And then last but not least, if you do not buy from a reputable breeder, we took care of that. It will cost you extra. It will cost you extra. All right. I'll name that R. It will cost you extra. All right. Now, if I want to turn each of these premises into a logical argument, all right, I'm going to go and do this in red. I'm going to do a red symbolic notation for each of these. So if you buy from a breeder, then your puppy will not require shots. All right. I might go ahead and say your puppy will require shots I'm going to change my simple statement, your puppy will require shots. So essentially this statement is saying that if you buy from a reputable breeder, P implies, right arrow, it implies your puppy will not require shots, so not Q. All right. So that's one of our premises. P implies not Q. I'm going to go and copy and paste this down here to keep formatting, but obviously it's not going to look the same at all. If you do not buy from a reputable breeder, then it will cost you extra. Do not buy from a reputable breeder, so that'll be not P, implies it will cost you extra, not P implies R. Not P implies R for our argument. Maybe I'll go ahead and code that in blue so we can differentiate. Last argument here, it will cost you extra. It will cost you extra is just the letter R. That's it. We don't have any ifs and thens. We don't have ands or ors to place in here. We have just the statement R. All right, and right down on the bottom, therefore your puppy will not require shots. Let's see if Microsoft has the therefore symbol. There we go. 3 dots together is the therefore symbol. Therefore, your puppy will not require shots. We'd say then, therefore, not Q. All right, puppy requires shots is Q, therefore not Q. Now here's what we're going to do, and if you missed last time's lesson, here's the basic gist of things. We're going to take all of our premises. So this this, and this, we're going to put ands between them. We're saying this is true, and this is true. And we're going to see if we can imply that the last statement is true. All right, so if I want to put this all together as a logical statement, I would say P implies not Q, and not P implies R, and wedge R. All right, so that's all my statements together, all my premises together that I'm making. I'm going to put brackets around this, and then I'm going to say that implies not Q. All right. Now I want to see if this is actually true, and you can follow along with me if you've already looked at number 5. I'm going to go ahead and make this into a table. All right. I need to ask myself first, well, how many rows will I need? I see 1, 2, 3 unique letters, so 2 to the third power, I need 8 rows. I'm also going to need, let's see here, I need P, Q, and R as columns. I need not Q and not P as columns. That's already 5. I need this implies is 6. This implies is 7. The ands between them, that would be 8. And then the overall implies would be 9. I'm going to need 9 different rows for my table. All right. So I'm going to make a table that's 9 by 8. And then I'm going to start putting in values. I'm going to say this is P, there we go, copy and paste, Q, R, I'm going to start with those. I'm going to say we have, let's go ahead and center everything, Control E. We have a true, 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 false, 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 and I need one last row. I didn't count correctly there. True, true, false, false, true, true, false, false. I'm going to try to do this in a decent pace, so pause the video if you need to write this down. Last I have true, false, true, false, true, false, true, and false. So let's see here. For this argument, I need a not Q. I need a not Q, so I'm going to go and type that in, not Q. I'm going to go ahead and take my Q column and do the reverse of all those. So I have a false, false, true, true, false, false, true, true. I need this P implies Q for my next section. Probably need to do a little formatting here. While I'm doing this, ask yourself, what does the implies look like? Remember, an implication is true only if, or almost always, except when you have a true implying a false. So here we have a true implying a false. That's a false. We have a true implying a false here as well. That's another false. But otherwise, we have a true, 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 and a bunch of falses. Falses implying anything are always trues. So we have trues the rest of the way down, all right, for our implication. Next step, I'm going to take our next premise. All right, this not P implies R. Not P implies R. You know what? I probably need not P, though, first. So let's generate not P. I see P goes true, 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 false, 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 so I'm going to go the opposite. False, 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 true, 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 true. Not P implies R. Not P implies R. Well, let's see here. We're looking for where we have a true for not P, but a false for R. A true and a false. Looks like we have one there. Looks like we also have one, not P implies R. We have one right there. But the rest of them are going to end up being true. All right, and again, that was this piece. So we're most of the way done with our truth table now. The next step, I want to do all of these ands together. So everything in these brackets, I'd like to do everything in the brackets together. I'm going to shrink that down a little bit just so it all fits appropriately. All right. So essentially what I'm doing here, and I'm going to do a little bit of color coding, I have my three premises. I have the, what did I label this? The red one, P implies not Q. I'm going to label this with red. And I'd strongly recommend you color code these as well in your homework. I'm going to label those with red. I have this, what did I do, blue premise for this one. I'm going to label this with blue. And I have the R premise, which is pretty straightforward. I'm just going to go ahead and label that with an orange. All right. If I want to take the ands of all of them, I need to find places where they're all true. I see in this first row I have a true, false, true. Since there was a false, anding all of them is going to be false. I need some place where they're all true. Second row, no. Third row, yes, I do have all trues. Look at this. We have a true, true, and a true. So that generated a true. Next row, we have a false, true, and a true. So that's a false. This next row, we do have all trues. Again, next row, looks like we have a false. Down here, we have a true, true, and true again. So we have true, and then we have some falses, so it's false. All right. Now, here's the very last piece. And in order to see this last piece properly, I'm going to go ahead and insert another column just before this one. I'm going to go ahead and paste this not Q column in. Oh, that's convenient. It did it for me anyways. I'm going to paste this not Q column in. Note that this is the exact same column as right here. It's just that this is so far away. If I want to do an implies, I'm going to go ahead and just do this. And then I'm going to go ahead and just say this whole thing right here that we have, this whole getup that we have right here, I'm going to call it just the therefore. All right, I'm going to call it just the therefore. Generate a shape. Why can I do that? Here we go. Oh, beautiful. Let's get rid of the fill. No fill. Here we go. So I'm going to call this big blue thing the therefore. All right, and I'm going to just put that in. Alternatively, I could just, you know what, might as well just paste it in, but make it incredibly small. But you know where I got it. It's the whole argument fitting on just one line. All right. Here we go, finally, good. So this last thing here, we want to do an implies between these two rows essentially. Remember this last row I just got from not Q. I just went ahead and copied and pasted it. You don't have to do that if you don't want to. I'm doing an implies with these two. So false, false generates a true. Next one generates a true, true, true. Uh-oh, we have a false. We have a false. We have a true implying a false. That's going to be a false. Then we have a true, true, true going. Here's an issue right here. If we have a single false anywhere in our overall argument here, I'm going to make the argument, let's say, yeah, let's go purple. Not a disgusting green, let's go purple. If we make the argument, if we want to make a quotient argument, we need to make sure that all of our conditions are true. Otherwise, if we have a false in this situation, we've got an issue. This is basically saying here, there's an issue with our argument when, let's see when that happens. When P is false, so when you don't buy from a reputable breeder, but your puppy does require shots and it'll cost you extra, our argument falls apart. All right, when you buy from a reputable breeder, it won't require shots, but maybe if you buy from a reputable breeder, it'll cost you extra. It doesn't cost you extra. There's a logical fallacy here happening with those conditions. So in this case, question being, determine if the argument is valid. This is an invalid argument due to this single false. We need absolutely all trues down this row. So it's a single false, so I'd say argument invalid. I really did not mean to do all caps. That looks a little angry, but oh well. Please come to class next time with questions, but all of your arguments that you do here, you can do the same type of setup. I don't know that any of these require a PQ and R, so the table should be a little more straightforward. But you're going to do the same type of setup. Again, we defined our simple statements off of our 3 premises. We did a truth table doing an and between all of the different premises and an implication of the last statement. And then we went ahead and saw if that general statement was true. If it wasn't, if there's a false, then there's some issue with our logic. Somewhere in our logic there's a big issue. I'm going to go and stop the video there, give a shot at that assignment, bring some questions next time, and we'll keep on keeping on. Have a great weekend.